All right, let's go ahead and get started. Notes, upcoming notes, and things to look forward to. I worked over this weekend and got chapter one, not chapter one, lab one grades out to you so you can see the results and some of the comments I put on it. A lot of you fell into the trap of getting that warning message about precision, while the other half resolved it. Kudos to the ones that resolved it. There are different ways of handling it, but good job in doing so. Chapter lab one grades have been out, so you can look at the comments and see what some of you might need to do better on the next lab. I only took a few points for each thing that I saw, like 2 or 3 points for each thing that I saw wrong. So the grades were really well. I hope they go forward that way. So let's carry on. I hope lab 2 gets a little bit more challenging for you, because each lab that we do is going to get more and more challenging, and I'm going to be a little bit more stricter on the grading, because now that I expect more from you guys. All right, today we will be going over, and in lab for chapter 4, we will continue to go over, use the same lab that we did before, so I hope you kept it. And then we'll do a review for chapter 4, because the quiz will be this Wednesday. Same time frame for the quiz. I should release it in the morning by 8, and then it will go on all the way to 8 p.m. Any questions on that? So let me share my screen.
I noticed that the video for the in-lab 2 is not on the YouTube channel or in the recorded lecture area.
Which one? The first one that we did for these seats one?
Yeah, the one that we're continuing on, I wasn't able to be here for the whole thing, and it's not in there, so I haven't had a chance to catch up.
Oh, well, I will email the Keith, or the email that I sent him to. He usually posts them, so I will remind him to post for chapter 3. Thank you, and I'll look that up. Chapter 3. All right, thank you. And share screen. But they should be on the downloaded lectures, so you can still see them. Correct?
So you sent us the link of when I go over to recorded lectures, there's the main link to all lectures.
Yes, that one right there, that's when he posts them. But if you still go to Blackboard, download recordings, if they're not posted there, they're still on the download recordings.
I don't see a download recordings option here.
Let me share my screen. I can show.
Okay,
Screen.
thank you, sir.
Share application. All right. After each class, can everyone see my screen now?
Yes, sir.
Okay. After each class, when the lectures are downloaded, I send them off to one guy at TCC, and that's where he posts them. And so when you click on recorded lectures and the main one, this is where he posts them. But if they're not there yet, because I email him every night, sometimes he might get busy because all the other faculty are sending videos too. If you go to Blackboard Collaborate, this link right here, and you should see recordings, and this should be right here in chapter 3. So you can watch them from here as well. But this place, I think you have to download them. But on the other place, you can just watch them and stream them on YouTube. But if they are not posted here at the other place, then he has not posted them yet. So I don't know if he's out sick or whatever, but I will follow up with him to make sure these lectures
Okay,
get
I
up.
found them. Thank you.
But they're always right here. Unless they tell me I'm running out of space, then I'll start deleting them. But I will, thanks for the reminder, if I have to remove them from here, I will make sure to delete only the ones that is already posted. So, I'll follow up with that. This is, remember when we did our in-lab before over the seed assignments? Our code was very sequential. We had the title, we display the title, we get the seed sold for A, seeds for sold B, C, and so forth. Very linear. So let's review what we did. Here's the code right here. I hope you kept it. I think it's also on Blackboard. When you run it, start without debugging. We can enter in values. It's going to display, oops, TBBC. There's one typo right here. This should be C on this one. But notice there's no data validation. So if we do something like this, start without debugging, and we type in negative values, we cannot sell negative value seats. We should never allow the user to proceed on if there is bad data. The big reason is you do not want, it's a big concept in programming languages that we talked about in my undergrad called the impossible rule. It's best to make an error never from being able to happen than it is to put a whole bunch of code afterwards after it's been committed. So if you can stop the user from doing something, then you don't have to worry about all this logic handling behind the scenes afterwards. And the same thing when you get to functions and security, a rule called least privilege. You give enough information for that function or person to do the task, but nothing more. So with that being said, to make this rule right here from never happening, what do you think we have to do?
Create an if statement that checks the value.
Very good. So when we start looking at our diagram, we don't have any kind of that flow, correct? Direction operator. Right here. And this should go right here. So our condition operator that we talked about right here was this diamond operator, correct? So I'm just going to do one because it's faster to write on the board. So what's our condition? Can I write something here? If seed sold, let's just say for A, is what?
Can we say that make an if statement saying if the variable is what's the user input is less than 0?
Yes, if less than 0, seeds A or less than 0. So this right here is going to no longer point here. It's going to point right here. And from right here, if it's less than 0, what do you want to do?
Inform the user they can't insert a value less than 0.
Well, in that case, we have to give them an error message, correct? Error message saying invalid data or something. So that if this is yes, so I'm going to connect it bidirectional right here. If it allows me, I haven't tried it right here. Oops. I don't want that dot. I want it here. And if this is true, we error out, and then we come over. Oops.
Hey, quick. I was gonna say, quick question for about the CN object.
Yes, I'm listening.
So didn't we learn? So you know how we learned it in, I think it was chapter 3 or chapter 2.
Mm-hmm.
Didn't we learn that the CN object has a property or method that's called cn.fail?
But that's the different process that we want to handle because CNFL is the actual reading of the value.
Yeah, so I was saying like if they don't put in an integer and they just put or a number, they put something like a string or a word or a character.
You might want to read the functionality on that one that might have some other scope with it when that dot cell is.
Yeah. Let's see.
So, because that might be handled in, because when you do it, you might also have to do a cn.reset to reset that back. Because that sets a bit in the cn object. So be careful and read the documentation when you do that. So right here, we got the cn right here. If it's less than 0, we error them out, and then we read in the value again. While it's no, if it's anything wrong, then we proceed on. And we would have that same condition over here and over here again. Does everyone see that? So now your first part is going to get more, it's not going to be so slow. See, it has multiple directions. Does everyone see that? So we would have this duplicated for A, B, and C. So no questions on that.
No.
Do what? So now let's go to our lab.
Are you expecting us to use looping for this or no?
No, looping is next chapter.
Okay.
It's next. We'll cover looping in next chapter and functionality on that one. So, and I'll bring that up in just a moment when we code this. Do not proceed on, when you do your labs, stay within the scope of the chapters we're in. So, as we see this, I want you to keep an eye that this is going to be duplicated over and over again. So when we start doing chapter 5 functions, I'm sorry, it's chapter 6 functions, we are going to take some of this part that's redundant out and replace them with functions and pass them as pass parameters to them. So we would only write it once and call it multiple times. But that's in chapter 6. But for each chapter, I just want you to gradually understand the concepts. So now, when you go here, as we said before, how can we test this logic right here to prompt the user to see if there is a value that's incorrect? How can we prompt them again? How can we error them out and give them give them a chance to correct the information?
Can you use an if statement to check obviously if the user ticket A is less than 0?
Very good. It's less than 0. Why not less than or equal to 0?
Because 0 isn't a negative number.
It's not a negative number, but is 0 valid?
I think so. It's valid because it's valid, but
Yes.
it's not.
Yes, it could be valid because you could have told no ticket for tickets A. So now we're gonna. How do we display a message to the user, giving them an error message?
Oh, an error message. C. Wait.
Yeah, you're right.
I feel like there's something else that where it like lets them type. Oh yeah, I think C out and then say please define a number higher than 0 or something like that.
Enter value greater than or equal to 0 because 0 is valid.
Mm-hmm. Yep.
So okay, now we give them a prompt. Then what?
I believe do we also use again cn and then we take that input and put in ticket A.
Copy and paste it. Let's see if it works for that one. I keep hitting my Windows S. This is a Windows machine, not a Mac. So I'm going to build it just to test it for that one. Rebuild solution. Debug. Start without debugging. So now if I enter -5, it gives me invalid data. If I enter valid 10, and I can keep going. However, debug, start. If I enter negative value here, and I enter negative value again, it's going to continue on. This is not a loop, which will later on will fix up in the next chapter. But for right now, same thing with your lab. Go ahead and just do one pass through and say, hey, I caught you, you entered invalid data. Please enter the correct data in. I'm giving you a chance before I go on. Anyone have any questions?
I have so far for so I don't have to do I do have a check for if the value of from the lab is less than 0, but I don't have to like return 0 and not do anything else after.
Well, in this case for your lab, if for Miles and so forth, you're going to do the same thing right here. Give them a message, give them a chance to correct it, and go on.
Okay, so I was gonna see what about if the first I can give them another chance, and if they still put in the correct one, then I can return it and not what after.
If you want to do it like that, but you don't have to.
I see.
You don't have to. So for on this one, I'm just going to take this, Control C. And all I have to do is change this to be seat B and seat C. And of course, and that catches me to make sure I do not get any invalid data. Yes, if they enter invalid data a second time, it will go on. That's covered in chapter 4 when you cover while loops, for loops, and do while loops, which will keep them there and constantly keep on repeating until the conditions break. That's why I really want you to understand the simple concept of an if statement, because these doing with booleans and the ands, ors, and nots that you put in this logic right here is sometimes the same logic that you will put in a condition to keep the loop going, like a while loop, a for loop, and or do while loop. So I really want you to understand the concept of an if statement and those conditions that we talked about, the ands, ors, and nots. So any questions for what we did right here? No? Okay.
Nope.
No. Good. I want you, when you look at this code, as we move forward, I want you to think about how we're going to later on enhance this. I mentioned before we talked about looping, which we'll cover in the next chapter. The chapter after that is functions. These chapters 4, 5, and 6 are the key deal breakers for this class to make sure you really understand it. Because as you can see, we're doing these things repeatedly over and over again, correct? I want, please enter the seats, please enter the seats, please enter the seats. And we're just reading into a different variable. Couldn't we think about writing that when you do chapter 6 as in a function and just writing it once and reusing that? So keep that in mind as we enhance this lab. I want you to spend more focus on the concept of that chapter, such as in the if statements, than it is to create a whole new lab. Because the in lab that we did, that you're doing now, due on Wednesday, you're writing different if statements, correct? That's all it is. And putting logic to it. So I want you to fully understand how the if else, or however you code it, works. So that's why I give you practice. Any other questions so far? If not, that's all for this lab, but we might go back to lab when we practice for our review. So we covered chapters 1, 2, 3, 3 with the formatting, 4 with the if statements, and chapters 1 and 2 with the see in and see out. So as you can see, we covered everything that we covered right now, except for such as a switch statement in chapter 4. So let's see how well you guys are good for the review and some questions I'll come up with. Let me go back to this. Close this. And go to... I hope everyone has their mic on. Where did that book go? No. Oh man, I lost my book. There it is. All right. Let's start from the list, and I might add on questions to it. Alexander, do you have your mic on?
Yeah, I do.
Describe the differences between the if-else statement and a series of ifs. What's the difference, and how is it handled?
Um,
So if you,
they're not. It's like they're not one after another necessarily.
well, they're right after another. So let me just add a source, another source file, and the item. So right now, what's the difference between of me writing a whole bunch of if statements like this compared to
So you can't do that with if else, so can you? I thought you couldn't do that.
if? Hold on. What the question is? What's the difference between these, else if, these? If followed by another if compared to if, else if, and I can say another else if. What's the difference between this and this? Because they're handled differently.
Uh,
I mean, the top ones are like true statements, right? So
Hold on. Let's see if he gets it before I go on. But thank you, though. Do you understand it?
I don't think I can. I don't know the correct answer to that
Okay.
exactly.
Who is the
I
one
can't
that was
tell
speaking?
for you.
Who was the one that was speaking up?
it's Jeffrey.
Jeffrey, go ahead.
So the difference between those are like they're pretty much like if, and they're seeking true statements. So like if this is true, it does that. If this is true, it does the next one. But with if else if, it's if this is true, do what's in here. Else, so for false, do this next statement.
You're getting on the right track, but what's it? You got one thing different between this one, this
Wait.
one.
If for the first one, if and if, it's identifies each statement separately, and then if else, if the first one is fulfilled, then it will not do else if, and then
Very
okay.
that's the key. You're on the right track explaining it. But the difference between this and this is this on if all of them are going to be evaluated and all of them potentially could be executed. While like you said before, if on the if else if it finds one that's true, it skips the rest. It finds the first one that's true. Very good. Let's go down. Where is Alexander Gary? On the next question, which I guess this is
It's behind your coding window. Oh, behind that one.
In an if-else statement, what is the purpose of the trailing if? Yeah, you don't know? What about if it's
He said something in chat.
It is second test for a true value.
well, because you might have an if-else, but the else is not required. But what is the purpose of having it? You don't have to have the trailing else. Like if you have if, else if, else if, else if, you don't have to have the trailing else. But if you do, what's a good purpose to have it? Let's go down to the next one. Joffrey.
Yeah, so the else is kind of like if all else fails is the way I think of it. So it's like it's a way to kind of close out a statement or a set of ifs. I know that's a terrible way of describing it, but that's the way my brain works. So the way that I've always used it was to, validate these items, but if nothing matches those, do this last thing here. And that may be like, tell them to try again or something like that. But
No, that's valid. That is valid. It could be used as the last condition. Like if the choice are A, B, C, D, and you only test for A, B, C, then the trailing else could be just for testing for D. Or it could be, like I mentioned before, the scenario that was missed. I tested A, B, C, D, but I want to put a trailing else to say, oops, how did I get here? So it can be used for multiple purposes. It could be for the last scenario. It could be for a catch-all, whatever. But I would accept that. Husan, what is a flag and how does it work?
Flag is like a variable you use to decide to check if something has happened. So you put it within. You might want to put it within an if statement, and then in the if statement you'll say assign this value true, and then you can use that flag later on in your code to decide if something has happened beforehand.
What data type usually is it?
Boolean.
Very good. Yes. And all it is, like it says, something has happened. And next one, can an if statement test expression other than a relationship expression? John?
Yes.
Yeah. Go ahead.
I mean, yeah, it can. Isn't it like a zero is
You get
the zero is false,
yeah, get that.
right?
You put true or false directly in it too. Yes.
Yeah. And then anything else is true.
Any non-zero is treated as true. Correct.
Yeah.
Justin Harmer, briefly describe how the ampersand works. What is it and how does it work?
It's an operator that is supposed to indicate if one condition it has to be true and that the other condition, both or every condition with that operator, they all have to be true.
What do we call that?
The AND operator. Wait, that's the
Be confident. You said it.
Oh my god, I better remember.
It starts with an A. You just mentioned it again. You just mentioned it when you were describing it.
The AND operator?
It's the logical and.
No, yeah, logical AND operator. My bad.
logical and, which you explained it correctly, both sides have to be true for the whole thing to be true. Now, to continue on to pressure you, if the first one is false, do I care about what the second one is?
No, you don't care.
But if the first one's true, do I care what the second one is?
You do? Yeah, you do.
What do we call that when the first one is false, but I don't care about that other value? What do we call that?
That's the logical OR operator.
No.
Wait.
What do we call that when I don't have to continue evaluating the other ones?
Oh, wait. So if one of them is false or true, and then we don't care what the rest of the ones are?
Yes, what do we call that? There's a specific term that's used when it says on the logical and, if I have A, if true, false, and this, if it's false first and I have an and, I don't care about anything else. I'm not going to go on. What did we call that?
I think we called that I was gonna say conditional, but that wouldn't make any sense.
Can anyone else help them?
Does it start with an S?
Sure.
Yeah.
Oh,
He just said it. Somebody said part of it.
short circuit logic.
So short circuit logic. Very good. That was Justin Michael on Michael Gay. Briefly describe how the pipe symbol operator works. What is it called and what does it do?
It's a logical or. It's either the first expression or the second expression, and it doesn't care if the first one's false. It'll continue going to find the true value.
But if the first one's true, we don't care about the other one, right? I didn't hear yes or no.
Yes.
The first one. Okay. Very good. So we on logic or, it's one or the other, or potentially it could be both. But since we short circuit, if the first one's true, we don't care. Very good. Murray, why are relational operators called relational?
I think they're used to compare numeric values if one is greater than the other.
Yes, you compare the relationship operations, you compare how they relate to each other, less than, greater than or equal to, and so forth. Very good. Stephanie, why do programmers indent the conditional executed statements in a decision structure?
Usually done so that you can easily distinguish that part and what part of the program is going to be conditionally executed.
Very good. It's like we did before on ours when we did the if, we indented it. I think Python or some languages require it to be indented, but for here, it's for clarity. Very good. Let's see. An expression using the greater than, less than, or greater than or equal to, or less than or equal to, or not equal to operator is called a blank expression. Alexander.
It's called
Look at number 7.
yeah, no. Conditionally executed statements in decision structure.
When you're using greater than, less than, or equal to, we use those type of what expression?
Oh, relational.
Oh, there you go. Gary, Gary, you don't have a mic, do you? Why not? No, okay, so I'll just go on. Joffrey. A relationship expression is either blank or blank.
Sorry, but a relational expression is either. Actually, I don't remember this off the top of my head. Let's see.
Well, think about what we're doing right now when you do an if statement. It's either what or what.
Oh, I guess true or false. Yeah.
There you go. There you go.
I guess maybe I was expecting it to be a harder question.
No, that's why I go over these questions so you can understand the way it's worded. Because that's the way it comes up in the quiz, that's the way it comes up in the exam. So I want you to get familiar with the way the questions are going to be worded before you actually take the quiz or exam. So, Usan, the value of a relation of expression is 0 if the expression is what?
False.
And I'm going to correct this one, or any non-zero is treated as?
Wait, you said any non-zero? Oh yeah, any non-zero is true.
But if you hover over, if you look on your IDE and you put false, all lowercase, and true, which are keywords, you will see, let me see if I can do it real quick. Seats. If I type in the word true, you hover over it, it's sometimes going to give you, maybe it's on a delay, but if you hover on some of them, sometimes they'll give you 1 or 0 right here. Let me see if I put it here. True. Oh, maybe it doesn't. Some probably delay. But if you put it, sometimes you hover over it, it'll give you IntelliSense to say true or false. Okay, that was who took the last one? Was that Hassan?
Yeah, that's me.
John Arnold. The if statement regards an expression with the value 0 as
False.
false. Justin Harmer. If the if value statement regards an expression with a non-zero value is
True.
true. Michael Gary. For an if statement to conditionally execute a group of statements, the statements must be enclosed in a set of
Brackets.
Go.
brackets. If you do not have brackets, what is the only statement that's in question regarding that if statement?
For Michael or anyone.
Hey.
This is a continuation on who answered the last question. It was
I'm sorry, say that again.
that was Michael. You says if you want to execute more than one statement, you must put them in braces or curly braces. If you do not have those curly braces, what is the only thing that's in question if you do not have it?
The first one?
The first statement after the if. Murray. The if else statement, the if part executes its statement or block if the expression is blank, and the else part executes statements or blocks if the expression is what?
I'll say if else. I think if the first part is true, and the else part execute its statement or block. I think that if the first part is false, then it executes the block.
But if the if part is going to be executed, it's going to be true. But if the else part is executed, it's false.
Yeah. Okay.
Stephanie, the trailing else in the if else statement has a similar purpose as the blank section of a switch.
It has the similar purpose as the default statement section.
Default.
Yeah.
Very good. 17, at the very top, Alexander. The if else statement is actually a form of a blank if statement.
The if else statement is actually a form of the blank.
Starts with an N.
I'm trying to think. I'm so bad at this.
Good thing it's a review, not the actual quiz, huh?
Yeah.
Can anyone else help him out?
I just don't get this.
I'll give you the hint. Nested if statements. Because it's nesting. If, else if, they consider that nesting that way, and they also consider nesting if you have if with inside it if. So that would be nesting. Joffrey, if the sub-expression on the left of the blank operator is false, the right expression is not checked.
And that's an and expression. Logical
And.
operator mean. Yeah.
Husan, if the sub-expression on the left side of the blank logic operator is true, the right side of the expression is not checked.
That's for the or logical operator.
Sure. Very good. John, Arnold, the blank logic operator has a higher presence than all the logical operators.
God, I forgot this. I went over this earlier, but I forgot it.
It's the only unary one we have. Starts with an N.
I can't remember.
Class, anyone else help them?
It's the not.
The not.
Oh.
It's one
Justin,
that
go ahead.
we haven't really used too much, so I'm sure that's why.
Justin Harmer, which one are we on? 21. The logic operators have blank associativity.
They have logical operators. Wait, what do you mean by associativity?
When you evaluate them, how do you evaluate them? So if you see ands, ors, nots, how would you evaluate them? Just like an expression. You would go from what side to what side?
You'd go, wait, what side to what side? What?
Like what side or outside? Like we're reading. This is kind of a question that's kind of weird the way they have it said. It's left to right associativity. When you have the operators, ands, ors, and nots, you read them from left to right, and then you go into the order of operation. So it's kind of like you're reading them.
Oh, don't you read it from like left to right?
Yep, left to right.
Oh, all right.
Michael Gary, the blank operator works best when testing a number to determine if it's within range.
Where'd he go? Jackson.
I'm not too sure about that one. Maybe I'm just not understanding the question right.
When you want to check a number that's in range, let's say from 0 through 100, would you use what kind of logical operator would you use to test it?
Oh, you're talking about like greater than?
Well, I mean, you're going to use those operators greater than, or equal to, and so forth. But when you're testing within range, what logical operator would you tend to use?
Or?
No. Because you want to go within range. Think about a number line.
Does it start with an I?
If you want to go through, let's say, 0 through 100, right? You want to test this part's in here. So you would write something, let's say, x is greater than or equal to 0 and less than this, because you want this side, because you have one range to go by. So if you're testing within range, you need to test with an and because it's within this and this. But if you're going to use one, you have this side to go for and then the other. So on that question, and. So that was Michael. Murray. So what's the answer to the next one? The blank logical operator works best when testing a number to determine if they're outside the range. Murray?
No, I don't know that one.
What's this number 23? What is it? We just went over it a moment ago.
I don't see number 23. What's the question?
The 23 right here. The blank logical operator works best when testing numbers to determine if it's outside of range.
If it's within a range.
This one right here, number 23, would be what?
I don't see a number 23. Maybe, okay, hold on. I didn't scroll my screen, sorry.
23 is right here. It's highlighted.
Yeah, I see it now.
Class, anyone to help them?
Oh,
Or Stephanie, a variable blank is only visible when the program is executed in that block containing the variable's definition.
Block?
Block scope. Very good. Alexander, you used a blank operator to determine whether one string operator is greater than the other. It's the same operator of the numeric. The what?
Assignment operator? No.
We determine if something's greater than the next, what relationship operator do you use? Same thing that you use in numeric. Anyone else help them?
Relational? Wait, a relational or no?
Greater than operator.
Oh yeah.
Joffrey, an expression using the conditional operator is called?
Sorry, my mic is acting up here.
An expression that is a conditional operator is a blank expression.
It's a Boolean, right? Not conditional. Conditional.
It's a conditional expression.
Sorry. I can't think of it off the top of my head.
The answer is conditional. The conditional. If it's a conditional operator, then the expression is conditional. Onto the expression that is tested by the switch statement must have a blank value.
Me?
Int. John Arnold, the expression of the following case statement must be blank.
Wait, which one?
28.
28.
It's 2 words.
Yeah, I see. I'm not sure.
Anyone else help them?
Is that some? Oh, must it have a case?
A constant integer. Integers are constant. 29.
Oh.
Justin Harner. A program will fall through a case section if it's missing a blank statement.
Break.
A break. Let's go through the. All right, everyone just put a message in the chat. I just want to see how good everyone is. So I'm going to put the chat thing on.
All right.
You put true or false. The 1 equal sign operator and the 2 equal sign operators perform the same operations when used in a Boolean expression. Very good. Oh, that is so good. I'm so happy to see that answer. A variable definition in the inner block may not have the same name as a variable defined in the outer block. True or false? I saw some truths in there. This right here, a variable defined in the inner block may not have the same expression. A variable defined in the inner block may not have the same name as a variable defined in the outer block. That is false. Because we'll see that in a moment, because you can have the same name in the inner and the same name in the outer. So you may not. So that is saying like this. If you have an if statement here, and I have a variable integer x, I cannot have that same value, integer x, outside. And I can do this. Remember, they says this one in the block scope of this one right here is invisible when I'm in this block scope right here. So let's see this again. We'll go back to, here it is. True or false? A condition executed statement should be indented one level from the if statement.
Wow.
Very good. That's true. All lines in a block should be indented one line, one level. Good. That's true. 46. It's safe to assume that all uninitialized variables automatically start with 0 as their value. That is false. Local variables, remember when we went to the debugger and I showed you those values within memory, what garbage values they have? Local variables. It is safe to assume that all initialized variables automatically start with 0. That is incorrect. It should never be assumed that they are 0. C and C++ do not initialize variables. Globally, they do, but
Can I ask a question about that?
yes.
Are the variables somewhat like a remnants from RAM that was earlier before?
Potentially, yes, because that's the address, that's the value that it's in there right now. Because remember, when you declare a variable int, it says operating system, I need 4 bytes to store this value. So whatever value is in there is used. And if you notice that if you try to use a calculation with it without giving it a 0 or getting the value, it will give you a warning message saying it's uninitialized. So is it safe to assume that all uninitialized variables automatically start with 0? No, they don't automatically start with 0. But those values that you see could be remnants from whatever's in memory at that location. Because remember, variables are associated with what? Each
An address?
an address. Very good. 47. When an if statement is nested in the if part of another statement, the only time the inner if is executed is when the expression of the outer if is true. True. That is true. 48. When an if statement is nested in the else part of the statement, as in an if-else if, the only time the inner if is executed is when the expression of the outer if is true. That would be false. When an if statement is nested in the else part, as an if-else statement, the only time the inner if is executed is when the expression of the outer if is true. This is saying the if is in the else part. So if I have this right here, sometimes write it out. The only way that this can be executed is when this outer part right here is false. That means I can potentially get to here. So sometimes write it out. That was 48. 49, the scope of a variable is limited to the block in which it is found. Oh, let me go look at this. That is true. Very good. You can use the relationship operators to compare string objects. This is number 50. True. You can use relationship operators. So now let's look at 51. If x is not equal to y, is the same thing as saying x is greater than y or x is less than y. True or false? Very good. If y is less than x, is the same thing as saying x is greater than or equal to y. Very good. 53, x is greater than or equal to y is the same thing as saying x is greater than y and x is x, one equal sign to y. This will be false because it's saying x is greater than or equal to y. Remember, this is going to be x is greater than or equal to y. This is saying x is greater than y, which is part of it. But remember, this is only one equal sign. So this is assigning y to x, not the equality. Check. So be careful with this. For this, we can go on, but let's just practice on with something else. So as we go through the review, I just want to make sure you are aware of things. Let's just say if I have this, let's just see. Even though this is not complete code, sometimes when I give you quizzes, I give you code snippets. I don't give you the entire code. If this comes up, will this cout print as true? Anyone can speak up. Will this be printed as true?
No.
Yeah, it will.
Yes, it will display as true. Will it still print out as true?
No.
Why would it not?
Well, firstly, not only is it equal to 10, that's which is not 13, but because you're not actually putting a true expression on if statement, and then that's not how you even check for equal relational operators. So that would be
This would still. Is someone else going to negate that? In this case, it would still print as true because this is an assignment operator. And inside here, that's still going to be assigned a non-zero, which is 13. And any non-zero is treated as true. Remember that. You can even, so in this case, it would still print as true, even though it's not a good equality check. Because remember, I kept on saying any non-zero is treated as true. That's an assignment operator saying assign 13 to x, and when you evaluate that, that is a non-zero. I guess I've been disconnected. All right, look, launch from. Hopefully I didn't lose my work. Can everyone still see my screen?
yeah.
Yes.
Okay, I guess it was just a VM, so I probably lost the assignment with the if condition, but don't worry, that's easy to put back in. All right. but it makes it problems to come up with given examples. Let me see if I can reconnect. TCC. Well, that's coming back. Let's quickly go over chapter 4, see if there's anything else I missed. Remember, true or false, be careful of the assignment, one equal sign, double equal sign. The if statement, how we just nested it, if it's just a single statement, it's going to, if it's not wrapped in curly braces, it's only the single statement afterwards, otherwise block it. We just talked about right here. No, on logic flow, if you applications, TextPad. I don't know if that comes, that's more sort. Text edit. Let me just add up another one. See if I can add. You know, I don't know if I can make this bigger. Let's see. I'm not gonna write. So if you have an if statement here, else if. Everyone see my text edit real quick, since I can't log into school.
Yes, I can see it.
So know the flow if you have questions. This is why we do indents, so it can be easily seen. So let's just say if I want to get right here, statement 3. I want statement 3 to execute. What does this if have to be?
False.
False. What does this else if statement has to be for me to get to statement 3?
True.
True. And keep going. What about this if statement?
Also true.
True. And what about this last one?
Still true.
Know stuff like this if you get these nested if statements on how to get this. Statement 3 is going to be executed, but also statement 4 is going to be executed because it's just in this scope, but it's still in this if statement right here that these is still going to be executed. So know how these work if I says how code flows. So be familiar with that. Let me see if there's anything else. All right, I think that's good. Let's go back to PowerPoint. Know how the logical and operator works, or works, and then the not simple, just not's the value. We talked about the flags. Any driven. The whole purpose of some of the things of all the labs now require data validation. Remember, some of the things that you can check for when it comes to user input are range, reasonableness, valid, and divide by 0. Comparing strings, you can compare them the same way using the same relationship operators that you have with the numbers, except that you know it's not going to compare A and B, it's comparing the ASCII number code with it.
That's only if you don't define A and B, right?
Excuse me?
That's only if you don't define A and B.
Well, it depends. Like on this one, they're just doing char cases. But if they're char type, you're doing the ASCII type. But if you have, let's say, integer A, then it's going to be the numeric because the data type is int.
Okay.
But if you're using a char value, you're comparing the ASCII type because it's just going to be the single part. Like this, ASCII part. See, this is numeric, but it's still comparing ASCII values. But if you have an integer named A and you assign it 10, it's not going to use ASCII equivalent of 1 and 0. It's going to use a numeric value, if that makes sense, what I'm just explaining.
Yes, it does.
Okay, very good. And let's see. This, be familiar with this. This is nothing but an inline if statement. If this part is true, then it executes this part, else this part. So be familiar with how that works. And same thing with the switch. We didn't go over it much because a lot of things in my years experience, I've seen it a few times. I've written it even fewer. The one I did do it, I thought it was kind of cool, but notice that when you do these case statements, you need to have this break in between. If not, it falls through. It's the same thing as an if statement, but remember, this has to be drilled down to an integer type, and these A, B, and C, that was a question they had to be compared to a constant integer type because these case statements cannot change. So that's why they put them as constant. And also be careful with an if statement with the semicolon. It kind of null and voids the condition and always executes. So be careful. And this part right here, with the same name, you can have this. You have an integer number outside the outside the if statement, but inside this main. Think of this as, and you can see more about it when you do chapter 4 and 5. Chapter 4, 5, and 6. This is what we call scope, block scope. This integer number on 14, once this line hits it, it asks for more memory from the operating system saying, hey, I need another 4 bytes to store this number. But once this closing braces end right here, this number in the inner side gets reclaimed by the operating system saying, I don't need you anymore, so it gets reclaimed, and the only one that you have left is the outside one. This CN right here cannot access this number on the outside. This is poor programming standard style when it comes to C and C++, because then you have number inside and number outside. So which number are you technically referring to? So you have to think of it as the context. And most other languages, they will not allow you to do this because when they see this int number in Java, it will come up with, I think it's redefinition of a variable. So other languages do not allow you to do this. Know that C and C++ allows you to do this, and that the scope of it is from this closing parentheses to this closing parentheses. If this number was not defined here, and it was doing int x or whatever, then you would be able to access the number on the outside. This number kind of hides that number. So you kind of lose functionality right there because you can't get the number on the outside. Any other questions or concerns regarding Chapter 4? I really want everyone to really understand how the condition works, how the logic operator works, and the do's and gotchas with this block scope and if statements, because all we're going to do next chapter is add more to it. Instead of doing ifs, we're going to do a loop which constantly says, stay in this block until a condition is false, then bail out. So if you don't understand how this works, then it's going to hinder you on the next chapter. So any questions on chapter 4? All right, if there's no chapters, I'll stay on a little bit longer for those ones that need help with their labs. Remember, your lab 2 is due on Wednesday, along with chapter 4 quiz. So if everyone's good and doesn't have any questions, I'm going to stop recording.